We're going to talk about choosing the best method to solve a quadratic. So we've learned 3 different methods to solve a quadratic: the square root method, factoring, and the quadratic formula. Well, if there's no bx term, we can use the square root method. So remember, no bx means if we had something like x squared minus 15 equals 0. X squared is the only variable, which means we're able to isolate it to take the square root. Factoring, you have to have numbers that are factorable, which means you have to be able to factor it into something in this form if you want to be able to use the factoring method. If you can't use the square root method and you can't factor, then you have to use the quadratic formula. Say it with me. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, the quadratic formula, remember, that's going to work 100% of the time, but it's not always the most efficient. So when we're talking about the best method, we're really thinking about what's the most efficient method, right? What's the quickest? What's just going to be the easiest for this problem? So we always want to just check and see if the square root or factoring would work first, and then if it doesn't work, we know quadratic formula is what we have to use. Again, you could always use a quadratic formula, but that's not the most efficient. So let's practice this. Example 1, x squared minus 2x minus 15. All right, well, I can already rule out the square root method. That's not going to work because I have a bx term. Negative 2x is my bx term. Okay, well, factoring. If it's factorable, I can factor it into my binomial times my binomial. Well, x squared, the only way to get that is x times x. Negative 15, I could do 1 times 15 or 3 times 5, both multiply to be 15. Well, if I want it to add to be negative 2, I don't think 1 and 15 are going to work. And since I have a negative 15, I know negative 3 times 5 or 3 times negative 5 both multiply to be negative 15. Well, negative 3 and 5 would be a positive 2. 3 and negative 5 is a negative 2. Hey, look at that. 2 numbers that multiply to be negative 15 and add to negative 2. Those are our magic numbers for our factors. Perfect, so we factored this. Now, to finish solving it, remember we're going to split these factors into 2 linear equations, and now these are easy to solve, right? We're going to subtract 3, so x could be negative 3, and we're going to add 5. X could be a positive 5. There we go. Those are our solutions. Let's do a couple more. Example 2, solve choosing the best method. Well, I notice immediately x squared minus 15 equals 35. There's no bx term. So since there's no bx term, the square root method would be the best method here. I'm going to have you pause the video and try that one on your own. Okay, let's check what you got. So remember, we want to isolate x squared. Well, to do that, I should get that 15 out of the way. So I could add 15 to both sides. So I'd have x squared equals 35 and 15 is 50. Great, well, now that x squared is by itself, I could take the square root of both sides. So x would equal plus or minus the square root of 50. Well, 50 is not a perfect square, so I'm going to break out my calculator, and I'm going to take the square root of 50 and round it to the nearest tenth. 7.07, well, that 7 rounds my 0 up to x equals plus or minus 7.1. And remember, our plus or minus just tells us that x could be a positive 7.1 or x could be a negative 7.1. Those are our 2 solutions. Okay, so we've solved by factoring, we've solved using the square root method. Let's do another example. Solve choosing the best method. 2x squared plus 1 equals 5x. Well, it's got that bx term, so immediately I know that the square root method is out. That's not going to work. So now I'm going to try factoring. Well, in order to factor this, or to use the quadratic formula, I need it to be equal to 0. So I'm going to subtract 5x. Right? So now this will be 0, equal to 0 like I want it to be. And my equation is now 2x squared minus 5x plus 1 equals 0. We could try factoring this. Okay, the only way to multiply to be 2x is if we have a 2x and a 1x. Remember, 1x is the same as just x. The only way to multiply to be a positive 1 is 1 times 1 or negative 1 times negative 1. Okay, let's try these out. That'd be a 1x and a 2x, so we could add to 3x. We're looking for negative 5. I don't think this is going to work. What do you think? Right, I don't think our 2 and 1 are going to get us up to negative 5. If we try our negative 1 and negative 1, negative 1x, negative 2x, hey, that's negative 3x. Nope, this isn't factorable. And maybe you noticed that beforehand, right? Maybe you were just able to tell, but this is not factorable. So what's left? The quadratic formula is left. That's our ticket formula. Okay, A is 2, B is negative 5, C is 1. All right, well, x equals a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, here we go. I'm going to zoom in on this. All right, well, I like to do the part under the radical first. So I'm just going to think about negative 5 squared. Remember, this is our discriminant. Well, negative 5 squared is 25. 4 times 2 times 1. 4 times 2 is 8. 8 times 1 is 8. 25 minus 8 would be 17. Okay, so my discriminant, which remember is the part under my radical, that's just 17. All right, let's rewrite that with the square root of 17. Well, what else can I simplify here? I know a negative 5 is really a positive 5, and I know that 2 times 2 is really 4. Okay, well, square root of 17, that's not a perfect square, so I'm going to break my calculator out again. So there are a couple ways we could do this. We could figure out the square root of 17 first, or we could type this into our calculator. Let's just figure out the square root of 17. All right, 4.1, perfect. So 5 plus or minus 4.1 divided by 4. All right, now we have to do this twice, where we add and where we subtract. 5 plus 4.1 divided by 4. 5. I'm going to do my parentheses. 5 plus 4.1 would be 9.1, and then if I divide that by 4, that'd be 2.275, which I could round to 2.3. There's one solution. Now we do 5 minus 4.1 divided by 4. Well, I know 5 minus 4.1 is 0.9, so really we're doing 0.9 divided by 4, which is 0.225, and that rounds to just be 0.2. And there is our two solutions. X could be 2.3. I'm going to write them at the bottom. X could be 2.3, or X could be 0.2. Okay, so when we're choosing the best method, right, we have to think about all three methods and then decide which one of these is going to be the most efficient. Again, that quadratic formula always works, which is great, but it does take longer typically than the other methods. So it's not always the most